course, the usual disclaimer applies. The consumption is just a tremendously important part of our economy. It accounts for about 70% of GDP, but consumption varies greatly across geography. And also how much consumption grows varies greatly across geography. And economists use this variation to look at how economic policies or economic shocks might affect one area of the country or another, and use this to test economic theories or measure the impact of shocks. And there's in particular been a lot of work looking at housing wealth changes and how that affects consumption and corresponding local employment. One limitation to doing this type of analysis is some of our key data sources on spending and employment tied to local consumption is restricted in its geographic boundaries. So for example, the economic census in the US is centered around the location of the firm, which is the county location of the firm. Similarly, the quarterly census of employment and wages, again, is centered around the employment location of the firm. But in reality, consumers are not restricted to geographic boundaries. Consumers cross markets boundaries to consume in other counties, and that cross-border consumption affects the revenue levels of firms and also employment in other areas. A way to see this graphically is through this diagram, where essentially these data sources are sort of siloed in how they view spending by county, when in fact we know spending is crossing borders. Those consumers that reside in County A can cross and purchase goods in County B, and those firms in County A can then sell to consumers that reside in County B. And so the purpose of this paper is to develop this consumption link between firms and consumers. And to do that, we're going to be using unique card transaction data from a large card transaction intermediary, Fiserv, that has information on both the location of the firm and the location of the consumer. And with this, we're going to estimate cross-county consumption flows between consumers and firms for every county in the US. And then we're going to show how this consumption link improves local economic measurement in a couple of ways. One of the ways we're going to show that this consumption link is important is through some really simple and basic regional economic accounting. And I'll show you what I mean there in a minute. And we're going to try to test the importance of these flows using that simple framework. And then we're going to apply these consumption flows to re-examine the effects of the Great Recession and how housing price declines from 2007 to 2009 affects consumption and local employment. And if there's time, I'm going to go into also some COVID-related research that's very preliminary. So before I step into additional details, I'll just give you a quick overview of the findings. So the first finding is going to be related to this simple accounting test. And what I have here in this equation is just a layout of this simple accounting framework that corresponds actually to the figure I just showed you. The basic accounting should be, if there's no cross-border flows, we should just expect household consumption in a county to be equal to how much is sold to consumers in that same county. Right? That was very, very simple, just those terms in black. But if there are cross-border flows, then we have to account for additional terms. That is, we have to account for how exports of consumption, how much firms are selling to consumers that reside outside the area, and also imports of consumption, how much consumers are leaving the area to consume in other areas. So we're going to set up an empirical version of this using corresponding empirical elements and test this. And we're going to reject the hypothesis that consumption actually stops at the county borders. That is, we think these flows are really important. Next, we're going to turn to an application of this, re-examining the Great Recession and some of the really excellent work done by Mian Rao and Sufi, looking at housing price declines and effects on spending and employment. And we really do confirm most of their main findings. We're not set to overturn any of their main results. We expand on the results, not just looking at the 900 counties they look at, but we look at all 3,000 counties or so in the US. And we're going to try to demonstrate the importance of accounting for these cross-border spending flows. And what we find is that ignoring these consumption flows can reduce the precision of these estimates, and it may lead us to underestimate the magnitude of these effects in local markets. That is, understate these effects by between 17 to 26%. Ignoring these flows can also misallocate where these effects might occur. So if you can think of a firm exporting or a county that exports a lot of their consumption to other areas, that local economic shock, the housing price shock in their market may have very little effect on spending because they rely more on consumers. Their potential demand is coming elsewhere. And so we should expect those shocks that are more distant to have a greater effect. And so for this reason, not accounting for these flows can lead to some misallocation of which employers are actually impacted. So with that, I'm going to start digging into some of the details. Two of the key data sources we use to analyze spending and employment are the economic census and also the quarterly census of employment and wages to give us information on spending and employment. But those data sources have been covered and analyzed a lot in other works. Our primary new or novel data set is from this company called Fiserv, which is one of the largest card transaction intermediaries in the country, with over $2 trillion in transactions going through their systems on an annual basis worldwide. So they're really large. And once the merchant signs up for their systems, all card transactions are going through their systems. This includes debit cards, credit cards, gift cards. Everything goes through the system. And on the Fiserv system, the data is incredibly detailed. And observation is just a single swipe of a card. We don't get to see the data at that level of detail. The data we receive has been aggregated and anonymized to the county level and by 3-digit industry codes. And in this data, we have information on both the firm location. So we have the firm location, and we also have a guest home location of the consumer based on an algorithm applied by the data provider. We also have an alternative cut of the data where actually the known home location of the consumer is also known for a subset of the cards. But those two data sets tend to match up quite well. So we kind of press forward with the algorithm that they apply, which seems to work quite well. Next, we focus specifically on 15 3-digit industries where the coverage is particularly strong. And we focus on the year 2015 where the data is also quite good. And these 15 categories account for about 79% of consumption if you exclude healthcare and housing. So it's a pretty big share of consumption. Some the data is suppressed in some of the smaller counties where there may not be that many merchants, and so for confidentiality purposes, we can't see that information. But for most of the dollars that we see transacted for high spending areas, we tend to see those corresponding flows. So for about 85% of spending in the US, we can match those up with corresponding flows in the counties. For the remaining 15% or so, we do an imputation process, and we have a lot of great information to perform that imputation. But again, we're not relying too heavily on the imputation because we have around 86% of spending covered with this flow information. So once we bring all of that together, we're able to estimate spending flows across all counties in the U.S. for these 15 NAICS categories. And then we can start looking at some interesting descriptives, such as the cumulative distribution of spending by industry as you move farther and farther away from the home firm's location. And this is the cumulative distribution of spending across different industries that's truncated at 1,000 miles. If this continued on, they'd all kind of go off into one. But you see some patterns here that you should expect. So, for example, for accommodation services, we see that most of it's the line on the bottom. You see most of the spending is occurring away from home. For food beverage stores, such as grocery stores, it's the orange line on the top. So most of that spending is happening in a nearby location. So you get kind of the general patterns that make sense. But if you're looking at any particular county, this spending distribution can look different for all kinds of reasons. The mix of industries, the local geography, the population, all kinds of factors. And so a nice way of summarizing kind of the differences across the U.S. is just to calculate net exports in every county. That is, higher level of net exports would mean that more spending is that firms are selling more to consumers that reside outside of the county relative to consumers leaving the county to spend. And those higher levels of net exports are shown in red, and the higher levels of net imports or lower levels of net exports are shown in blue. And you can see here there's just a huge amount of variation across the country, and so there seems to be a lot of cross-border spending flows. And you see a couple of patterns that you can recognize right away, such as Hawaii is shown in dark red there at the bottom, meaning that they're selling a lot of their consumption to consumers that reside elsewhere. Similarly, Las Vegas, Nevada shows up as dark red. It's kind of hard to, if I can point it out here, it's this area here. So we see all of these spending flows. They seem interesting, but can we validate these flows? Do they actually make sense? And to first, our first step to validate these flows is to check it using this accounting relationship I mentioned previously. So what we want to do to test this is we want to come up with empirical components to each of these pieces, and then test this relationship empirically. So on the right-hand side, we're going to turn to using the economic census of how much is sold in every county in the U.S. by firms, and then we're going to use a mix of that amount sold across the U.S. and this the expenditure shares going across areas, those spending flows, to calculate the exports of consumption and imports of consumption across every area. So that's going to cover the right-hand side. We're going to form those. There's imperfections there, but we think they're pretty reasonable. And on the left-hand side, we need an independent measure of household consumption. So to get at that, we turn to a measure of income and an assumption that people have homothetic preferences. So we're going to assume that basically there's a share of their budget that's going to these 15 industries. And we take a very, just look at that national share going to these industries, and we apply that everywhere. And this, of course, has measurement error on that left-hand side, but that measurement error would just tend to have us not find this relationship between these variables. So what we want to test specifically is if these beta-2 and beta-3 coefficients are significantly different from zero. That is, do these flows matter at all? And then if this really is an accounting relationship, we should expect all of these terms to equal 1. That is, we're just talking dollars going across borders. That's what we should expect these coefficients to be if this was a perfect relationship. And we run this year by year from 2002 to 2017. And in each year, we find exactly what we might expect. All of these coefficients are significantly different from zero. And we find that the coefficients center around 1, which we use.
Abe,
yeah.
This is your sort of 1-minute presentation to 5-minute Q&A warning, but we have no questions, so you can feel free to move on. Keep going if you want. Okay,
great. Thank you. Okay, so that's the first step is we do have some validation here of these flows. And now we're going to move on to this application from the Great Recession, keeping in mind that these flows were relevant even all the way back to 2007, over the period of the Great Recession. What we want to do here is then look at how changes in housing wealth affect spending and employment at firms, keeping in mind that consumers can spend at multiple locations and across counties. So again, we're going to be following this previous work by Mian Rao and Sufi and Mian and Sufi. And to do that, we first need a measure of housing wealth change, which we're going to get from Zillow data, just calculating the price change from 2006 to 2009. And then we need some way of weighting these housing wealth changes across markets. And what we do is we basically view these spending flows across markets as capturing potential demand for services across areas. So the first thing we do is aggregate these spending shares, and then we're going to apply these shares as weights. And the way this weight will work is, so if for example, there's 20% of your customers are coming from a particular county, then you're going to want to weight that particular county's housing wealth change by 20%. So again, we view these flows as capturing this potential demand across areas. And we can break out this housing wealth shock into a home shock from consumers that reside in the same place as the firm, and also an export shock from those consumers that are traveling there to consume. And then we apply the standard, or I should say the same model that was applied by Mian Rao and Sufi, where the left-hand side is either changes in spending or changes in local employment for the non-tradable sector. And on the right-hand side has this housing wealth change variable and the same set of controls that they apply in their analysis, two-digit NAICS shares. And I should say in the paper, we do all additional kinds of robustness checks, panel estimates, and also instrumental variable analysis. But here I'm just showing you the simple linear version. And when we apply this, these are the main results that we find. The first column is showing the relationship when there is no flow accounted for. It's just a local shock. And we see that coefficient is positive and significant. But in the second column, when we incorporate these flows, we find that the magnitude of that coefficient increases by around 20%. When we include both of these in the model together, in the third column, we find that the coefficient with the flows is positive and significant, and we get no effect on when we don't account for flows. And we can also break this up into the home effect and the export effect, where both of those pieces are positive and significant. And so you can actually divide these up. We get very similar results across the board when we look at employment.
Yeah. This is your 2-minute warning.
Okay, great. Another way of viewing this is more of a discrete version where you just break counties up into high export areas and low export areas. And where quartile 4 in that first column would represent the high export area. And on the right-hand side, we can just put two simple measures of housing price changes. The housing price changes for the consumers in your local market, and the housing price changes for the typical consumer that's arriving in your county and purchasing. And when we do that, we find exactly what you might expect. In those high export counties, the local shock doesn't really matter at all. The local housing price change doesn't matter. It only matters the housing price change from those export, where your customers are essentially coming from. Where in those counties that in quartile 4, where the export share is low, when quartile 1, where the export share is low, all of that housing price change, the only housing price change that matters is the local one. You get the same effect whether you're looking at spending or local employment. So in conclusion, we think these flows are really important, and we've showed evidence in a couple of different ways about how they may be applied. And with just a few more seconds, I can talk a little bit about how this might relate to the pandemic. Basically, the pandemic has really upset how spending flows have changed across areas. I think over the time period I was looking at, these flows were relatively stable, but the pandemic has essentially caused a lot of these export flows to just stop. And so our hypothesis, in looking at the pandemic and recent spending changes, is that it's going to be those counties or those states that have high export shares that are going to be particularly hard hit by the pandemic. And so in very, very preliminary analysis, we use some daily spending data information that we have, which is an alternative cut of this FISER data, and you can apply that.
Minus 1 minute warning.
Okay. And basically, all I'll say there is that we get exactly what you might expect. Those kind of looking at an interaction of export shares and the pandemics over time, it's those high export areas that are getting particularly hard hit. Yeah, and that's it. Thank you.
Yeah, thanks for that great presentation. So now we'll turn it over to my colleague from the Bank of Canada, Kim Hune, who will be talking about liquidity in Canada during the coronavirus pandemic. Kim, I think you might have the presenter ball now.
Yeah, I think Leland is gonna present,
Oh, okay.
Yeah, that's
Leland?
me. Thanks.
and Leland is getting the ball. You should have the ball. Please
Okay,
don't
it's
press
allowing me to
Control
share
L
now.
or Command L if you have a PDF.
I do. I have some slides up here that I'm sharing right now. And can you verify that
They're coming.
I don't think you can see my slides, can you?
No, we've seen it starting.
Okay, so
Share
I'll
it
share
together.
it now, sorry. And
You have to select PDF or PowerPoint depending on the presentation that you have. Okay.
here it is. Can you see it now?
Yes. Now you go to View and Full Screen. View up there. File edit view up there. Top left.
Say again?
You have to go to View on the top left and then Full Screen mode.
Full screen, full screen. Oh,
Yes.
but not Control L. Okay, I see.
Yes.
Thank you.
Perfect. Thank you.
Thank you very much. And I appreciate the invitation to share our work. It's joint work with other colleagues in Canada, the United States, where I'm in Florida, and the Bank of Canada. Regardless of the affiliation, I have to say that the views expressed in the paper are solely those of the authors and may differ from the views of the Bank of Canada, and no responsibility should be attributed to the bank. Standard disclaimers apply. And so I don't have to tell you all how important the coronavirus has been in economies worldwide. But what I can say is that if we take a longer horizon on this, compared to historical events, disruptions to the economies like the Great War, World War II, the financial crisis, those have taken place over a longer horizon. And so where that comes in is that traditional survey instruments and macroeconomic variables are measured less frequently. And what's different here is that we seek other data sources that are measured at higher level of granularity and also more often to be able to get around the time aggregation and the effect of variables with dependence that we're dealing with here. And so we do two things. We study some data from a consumer credit reporting agency in Canada, and we give some evidence of the situations around liquidity constraints for consumers, particularly with credit cards. Our methodological contribution here is a variation of intervention analysis, and we apply it to these credit card balances to be able to pin down a law of motion for credit card balances over time and create a counterfactual forecast of what might have occurred had the pandemic not struck. And we can compare that to what occurred during the pandemic to size up the effect in terms of credit card balances. So a little bit about the data here. There are about 30 million Canadians with credit cards. Not everyone has a credit card, but most do. We cover most of the population of Canada from our data set. And we observe accounts every month for several years, and it's quite a lot of data. And we have the luxury of trimming it down to design a sample just for this question. 3 years back, we pull a random sample of 1% of the database, and it's still tens of millions of balances. So it's more than enough to address this question according to a power analysis we've taken up. But if I get right into it, bird's eye view, the aggregate figures here. This is 4 years of data in average terms per consumer. We have balances on the order of 3,500 that people typically carry in Canada, up to more than 4,000. And what we can see after 2020, after the peak of January, is that there's this precipitous decline in credit card balances that's occurred during the recession. And that's something unusual for a recession. In particular, it's gone down below the level several years back. But what we can also see is that there's this backdrop of this rising trend over the years and a distinct pattern of seasonality, a peak at the end of the holiday spending season around New Year's Day, and then a decline throughout Canadians' tax season when people pay down their balances. And so these are all factors that have to be taken into account with a technique that we use. And so in particular, we studied the time series behavior of this, and we can see from an autocorrelation function, there's quite a deal of dependence in the data. But moreover, there's in the cross section, the distribution looks non-standard, I would say. This is not your typical bell curve type of distribution. It's it's skewed to the right. There's a lot of mass way out in the tail. But there's also the first bar of this histogram is a point mass at 0. There's a sizable fraction of the population, 15% of the balance of exactly 0 from month to month. And so this is something we need to take into account. We cut them up into different categories of increasing width, which explains the jagged nature of this. But overall, this distribution with equal sized bars would look like a 0 inflated exponential distribution, let's say. So putting those together, period after period, current to past, we have a joint density of these, and we can see that there's still a point mass at 0, 0. Customers with 0 balance now have 0 balance in the future, not much mass elsewhere. But if I look at it from the point of view of level curves, we can see most of the mass is in the 0, 0 corner, but quite a bit along the main diagonal. So the dependence is really important here, but also the nonlinearity with the interaction with the 0. Now, if I consider the conditional density of future balances conditioned on the current or the past, the distributions across each level differ from each other. They all have a mean and a mode near the current balance or the past balance, but the current balance is also more widespread or less widespread depending on where it is. It tends to stay close for very high balances or very low balances at 0, but in between the distribution changes. So there's a good deal of nonlinearity in this process, and well, we have to take into account all of those things. And so, in particular, what many techniques are unable to account for is transitions from a boundary to the interior, or from the interior to the boundary at 0. And otherwise, we also explored using panel data type approaches here, but those are problematic as well because the panels unbalanced, there are gaps between observations. We have to make do with what we have, a lot of observations with consecutive pairs for individuals, and that's enough to identify the law of motion for the distribution with the technique we use. Now, what we do basically is we cut the distribution into a histogram, cut everybody into K+1 balances, and get a vector of proportions of consumers in each category. That's the short version. And what we're doing is we're modeling the law of motion. And so we estimate a transition matrix. And it looks like what you think it does. And so that's fine, which transition from each balance category to another. But there's a lot of parameters in this matrix when we've cut it up, several hundred in particular. But we've also estimated each one of those elements of the matrix with a multinomial logic transformation. This is a very flexible technique, but it's also scalable with a large data set. And there's a lot more room to expand this technique for other applications, but using home ownership status and seasonal indicators by month is enough to identify the effect we see with the coronavirus. So what we do with this transition matrix is that we produce forecasts. We left multiply against the vector of proportions in each category, and we were able to estimate forecast one period out, left multiply again, and so on, and get a series of forecasts of the proportions of consumers in each balance category, starting from the beginning of the year in January 2020 before the pandemic struck. Now, how do we compare differences between distributions? Well, we take the forecast proportion that we would expect to be there given the law of motion we've identified, and we compare those proportions with the actual. And so in each bar of a histogram, the pair of histograms, we take the log difference, multiply by 100, and it gives us the percentage change in the proportion of consumers in each of those balance categories. Now, if we take a weighted average of those, weighted by the probabilities under the null hypothesis of no effect of the intervention, appropriately normalized, this is a chi-squared statistic, and in our power analysis and simulations, it seems that even tens of thousands of customers would be enough to obtain the asymptotic distribution. So we use this metric to be able to determine whether or not changes have occurred. And so we do it in two ways. First, we conduct a test based on a fixed transition matrix. So if we were to use a simpler model with the one transition matrix being applied repeatedly over the months, and another model that incorporates seasonality. And so we estimate separate transition matrices using monthly indicators as covariates, and so we show those results as well. We make this comparison across two different horizons. we consider one step ahead forecast month by month throughout the pandemic, but also L step ahead forecasts, L months from January 2020 to see the accumulated effect. And once we see those differences, I'll walk through some of the differences in graphical form. Okay, so a table of results here for L step ahead forecast. What I can see is right away in the fixed column, if we don't allow the matrix to change over time, we can see the numbers are quite big for a variable that's distributed chi-squared 28. And so it's in the hundreds, and so the p-values are effectively zero. So we're finding that we're not getting an adequate characterization here, but we do notice that things change by orders of magnitude in April and May. And so it's quite a large difference we can detect nonetheless. But if we compare that to the version of the model that has monthly transition matrices, the first few months, February and March, we're seeing numbers that are very close to what we would expect under the null distribution, but a sizable change in April and May. They're quite big changes. And then we see the distance recedes somewhat, but is still quite large forevermore after April, as far as we can see into the data. Well, one period at a time, we can see what happens. Again, the matrix, the fixed matrix is not enough to adequately characterize the data the way it is, but you can see something happening in April. But the monthly model, you can see 1 month ahead if we condition on what happened up to the previous month. Distribution of variables very similar to what would happen under the null. Big change in April, quite a big change in May, but then not much happening in the months to follow. And so, given that that's where we should look, I'll show you what this looks like graphically. And so this graph, I'll show a few of these. This is in March 2020. This is a comparison of the histogram that we forecast versus the histogram of consumers in balanced categories that actually occurred. And so each element of the bar, each bar in this graph shows the percentage change in the proportion of consumers in each balanced category. And what I can see here is that, well, there's not much action happening. So we had a statistic in the 40s, not far from the critical value of the 5% level, not much change in the distribution. But if I fast forward 1 month to April 2020, things start happening. And so what we see here is in the first bar, we see that there's 10% more consumers relative to our forecast with zero balances. And the next bar, the biggest one here, about 18% more consumers with balances on the order of $1 to $250. But we see overall increases in the number of consumers with balances less than $1,000. On the other side, we see fewer consumers in all the categories with balances above $1,000. And in particular, we see the largest changes in the proportion of consumers with balances in several $1,000s, $4,000 to $8,000, 20% fewer consumers. This trend continues. The next month, we still have 10% more than we'd expect with balances of zero, 25 or so percent with balances less than $250. Still overall an increase in the proportion of consumers with balances below $1,000 and a decrease in the proportion of the consumers with balances above $1,000. And now the difference between the proportions of consumers we'd expect with balances between $3,000 and $10,000 is now more than 20% lower than what we would have expected. But still, we're seeing sizable changes in the proportion of consumers with balances in the tens of thousands as well. And so if we continue on to June, it recedes somewhat, but the pattern's still similar. More people with balances less than 1,000, fewer people with balances more than 1,000. Likewise, in July, it smooths out somewhat, but the effect is still there and quite sizable, in the neighborhood of 20% decrease in the proportion of consumers with these very high balances. August, a very similar story. And so at the end of the day, what I can say here is that we discretized the distribution of credit card balances by month. We estimated a Markov model for this law of motion and tried a few specifications. One was flexible enough to be able to characterize the data. We used this model to forecast the distribution starting from the period before the pandemic struck. And then we made a comparison of the distribution we forecast with the distribution of credit card balances that actually occurred. The significant change that we found was in the months of April and May, and then things tended to level off after that. So it gives us a persistent change in the distribution that seems to be holding up to the most recent vintages of data. Overall, we found more consumers with zero balances, more consumers with balances below 1,000, and we found fewer consumers with balances above 1,000. And I guess what I could say on that point is that this is an unusual situation for a recession, is that you might expect that balances go up in a recession, in the sense that consumers have to draw down on savings and build up credit balances. And this is something that went the opposite direction than what we would expect. And it makes it a very different picture than what typically happens in a recession, because consumers so far might exit this situation with lower debt levels and higher savings than they might otherwise. And so it remains to be seen what exactly will happen here, because it's not the usual situation in a recession. And so with that, I'm just about out of time, so I'll hand things over to the chair, but thank you very much for your attention.
Thank you very much. You have 26 seconds left. So thank you for that nice presentation.
Thank you.
First, I'll ask the audience if there's any clarifying questions that came up. If not, I have one quick question I could ask. So since we're ahead of time, I can maybe ask this question rather than wait for my discussion. But you mentioned about power analysis. So do you have enough observations to sort of distinguish an alternative hypothesis where basically there's a level increase in sort of liquidity for all categories? So, because it seems like that's what's happening in the data, is that you sort of everyone gets more money due to CERB or something, and then it shifts the balances back.
Yes, we do. This is robust to detect that kind of changes. And actually, there's quite a variety of alternatives you could consider, because there are many ways that the distribution could deviate from what's in the null hypothesis. We considered that people move one direction or the other, but an overall shift in all categories. There's still an equality to 1, but any change of that form, or equality to 0, to maintain equality to 1 in the distribution. But it can detect a variety of changes so far. But what we might see is the power level of the distribution dependent on the type of change. Well, we pulled a sample size that was orders of magnitude bigger than what we found we'd need for a variety of such alternatives. And so we considered quite a few and decided to go well over what we needed to identify most, with power levels above 95%, as far as we could tell.
Okay, excellent. Thanks.
Thanks.
I guess we'll turn it to our next presenter, who is Tomaso Rodrigo, who will be talking about tracking the COVID-19 crisis with high-resolution transaction data. So with that, Tomaso, I'll turn it over to you. And I'll give you a warning at the 15-minute mark.
Don't press Control
L. Don't worry. Could you see my screen, right?
Not yet.
Hello?
Yes, now we can.
Yes.
Now?
Perfect.
Okay.
Right.
Perfect. Thank you. So hello everyone, and thanks for connecting to our presentation. We are going to present you one of our latest work that we did together with Stephen Hansen, Vasco Carballo, Jose Rodriguez Mora, Álvaro Ortiz, and another colleagues from the bank, where we monitor the COVID crisis using high-resolution transaction data from BBVA. This is the second largest bank in Spain, with presence in many other countries too. Okay, so the COVID pandemic, as you know, has emerged the importance of using high-frequency data to measure and track the impact of the virus spread, as well as the lockdown measure implemented by different countries. Particularly, using transaction data from BBVA, we are going to collect all the payments with credit and debit card from a BBVA client, as well as all the payments collected by BBVA point of sales, to build a proxy of consumption in real time and high definition. Of course, one of the most important parts of the project is to check the robustness of our data for the analysis, assuring their quality and representativeness over the whole period. This is indeed the most time-consuming part, where we put special care to clean, transform, and test the data. Once we have it ready for the analysis, the potential is huge. We have been working during the last 2 years in an ambitious project to measure national accounts in real time and high definition with financial data coming from cards, but also from bank accounts. From this big project, different applications arise. Today, I'm presenting here one of them to use card spending for nowcasting aggregate consumption, as well as to make granular economic analysis. We use these developed indicators to understand the adjustment expenditures during the crisis in the case of Spain. Then, in the lighting session, one of my co-authors, Álvaro Ortiz, will present another application to measure investment in real time and high definition as part of this big project. Okay, so let's move to the data. As I said before, we got all the transactions at BBVA operated point of sales and the ones done by BBVA credit and debit cards. Of course, avoiding the double counting and duplicates. Our sample goes from the beginning of January 2019 until the end of June. Nevertheless, some of the graphs that we are going to see now are updated until the end of October for the presentation. This table here collects the descriptive statistics in the case of Spain. We are working with 2.1 billion of transactions, with geographical detail, even at postal code, sectorial detail with 76 different categories. We also consider 6 million of cardholders with information about their postal code, education level, and age. It is important to notice also that all this type of data we have for the countries where BBVA operates, that is Argentina, Colombia, Peru, Mexico, south of US, and Turkey, including around 3.8 billion of transactions. After testing that our BBVA expenditure data is a coincident indicator and a valid proxy for consumption, what we did and what I would like to highlight is just two main advantages of our indicator. One of them is that we can have fast and timely answer to the evolution of expenditure, getting the BBVA data between 1 and 3 months ahead to the release of the official data. This time advantage is especially important for emerging economies, where the official data is more scarce. Moreover, this transaction data has a great detail that is not available in the official figures, like consumption categories or geography, as I said before. But also, we have another features to explore, like, for example, the disaggregation of virtual and physical point of sales, the information about ATM withdrawals as a proxy of the use of cash, and also we can identify if the payment is done from a national or a foreign card. The small graphs below are some examples for Spain and other countries of this type of analyzed data. Okay, once we have cleared the data, let's go to the results. Here we present a global overview of the impact of the COVID crisis on expenditure patterns across countries. For each of these countries that you can see here, we aggregate all transactions at a daily frequency and compute the moving average of 40 days and the year-on-year growth rate, presenting them in percentage point deviation from the pre-COVID period, in order to take into account that we are working with nominal data and different countries are experiencing different inflation rates. So then each timeline here should be interpreted as the total percentage point decline in daily year-on-year growth rate relative to the average growth observed before the crisis. From this global picture, we observe a cross-country heterogeneous impact of the pandemic. There was a large and fast decline in global expenditure at mid-March in most of the geographies, as you can see here, and then a global recovery since the end of April. However, the speed of this recovery is different by country. It seems that the slowest recoveries are in South America, particularly in Argentina and Colombia. Peru, however, you can see here that was the most hit economy in March, but the recovery trend was really good, reaching at the end of October a positive growth rate. In the case of Spain, for example, you see that the recovery trend started to change at the end of August when the pandemic situation worsened. Okay, so we also test that this with cross correlation, that the largest declines in expenditures are associated with the lockdown measures imposed by governments. So here in the case of Spain, you can see it really well. Here we observe that the week ahead of the lockdown, it was an increase in expenditure in anticipation to it. And then we have this sudden decline of 60 percentage points in the series when it was implemented. And it remained depressed until the end of May. Then basically the easing of restrictions after the early May across the 4 further consecutive phases was implemented in different provinces at a different times, taking into consideration that the health situation was different, okay? So here in this slide, what we can see is that the impact of the measure on expenditure was different for all those provinces. We have here 3 graphs where we see the time events for provinces that change to phase 1, 2, or 3, comparing with the provinces that goes to a more restrictive phase. And what is the evidence that we can have here? That different expenditure paths emerge in provinces that has a different phase in the easing process. Especially this differential recovery pattern emerged in phase 1 and phase 2. We also did some regressions in order to prove these statements, and indeed phase 1 and phase 2 are the most the phases that contribute most to the strong recovery of the economy. Okay, then we are going to explore the evolution of expenditure by category and income. Here we compute consumption shares in each of the 76 categories that we have across Madrid postal codes, and then correlate this individual share of categories with the data that we have from income per capita, from the household budget survey, okay? Validating that our card spending indicator could be used as a proxy of income. Particularly here in the table, we see how income affects consumption with categories across Madrid. And you see that higher income postal codes are associated with more spending on restaurants, health, and travel, and also in time-efficient transportation like taxis or parkings. However, low-income postal codes are associated with spending on essential goods like food and household care. This provides an important insight about how differences in income could translate into investment in personal care, into access to leisure, and the trade-offs between time and money. So this could be also, this type of data could be also used a time use survey. Okay, now going to the study of the expenditure reallocation given the crisis, we analyze the chain of expenditure patterns across categories during the study period, okay? So here you observe the consumption share that were quite stable before the lockdown, and then we have a clear reallocation pattern, where spending in food and hypermarkets, supermarkets, grows significantly, supposing over half of the total expenditure at the end of March. And at the same time, we see like other sectors like fashion or leisure collapse totally. Once the restrictions ease, the composition of this expenditure pattern return gradually to the previous distribution. Taking into account the expenditure growth during the last month in October, we checked that food expenditure is increasing by 40 percentage points comparing with the pre-COVID crisis. And among the most stagnant categories, we have travel and accommodation, for example. Okay, now let me explain that we also study how spending patterns have been affected during the lockdown to different groups within Madrid postal codes. So here you can see the aggregate evolution of expenditures by postal codes group in 5 average income quintiles. So you see that there are really important different results apart from the common dynamics observed in the rest of Spain during the lockdown and the recovery. You see that different groups of income were affected differently. The fall in expenditure is largest for sure in the richer neighborhoods than in the poorer ones. And this is why the restrictions affected more the pattern of consumption of rich people, moving away from luxuries goods toward the essential ones. And this recovery, however, at the end of May, affects all the income groups in the same manner. Okay, now let's go to the next one. So here what we are going to see, here. Given the importance of mobility patterns during the COVID crisis, we also build an expenditure-based mobility proxy using these BBA data categories that are related to transport. So here the idea is that when individuals spend money on categories of transport, we see that they do so because they want to move, okay? So comparing with the Google mobility data in the first graph, you found a very tight relationship between the two series during the lockdown. So taking this into account, we are going to explore heterogeneity across Madrid postal code in mobility. So in the second graph, here you can see that transport spending reductions during the lockdown are significantly lower for clients living in the lowest decile postal codes by income per capita, comparing to those that are living in the highest decile. This difference emerged particularly during the working days, suggesting that mobility differences across income groups arise because of works that is, not because of preferences. So if we disaggregate this by type of transport, we are doing that in the paper, you are going to see that we are going to find higher income household decrease significantly the share of spending in public transport, but the lowest income decile does not do that. So this is really important because from this another question arises, and it is, are lower income population relative more exposed to infection? And for doing that, we run a simple regression model to see how this mobility pattern would impact disease, okay? Testing for different variables. And what we find is that there is a positive and statistically significant effect.
Tomasa, this is your 5-minute warning.
Okay, thank you so much. There is a positive and statistically significant effect of urban transportation spending on current cases, okay, which supports the idea that traveling in Madrid during the epidemic increased the probability of infection. How much COVID cases in the lower income neighborhoods would fall if households would reduce their urban transport spending to the level of the richest one? So here you have this contrafactual exercise. So imposing the lower income decile, the urban transport spending on the top income decile, what we found is that there is a significant decrease in the percentage of COVID crisis for low income people. So just to conclude, let me say that we prove in the paper the usefulness of this transaction data to assess the economic conditions, capturing relevant patterns in spending in real time and high definition, at aggregate and at micro levels, which is very useful for policymakers and researchers, especially in emerging countries where they don't have so many data. We study in detail the impact of the COVID crisis on expenditure, the initial shock, and the recovery across countries, as well as the expenditure adjustment across categories and income groups. And finally, we test that transportation expenditure can be used to explain disease incidence, which also varies across income groups. And with it, I'm finished. So thank you so much for your attention, and any question, I will be happy to answer it.
Great, Tomasa. I'm stepping in because James had a little problem at home. There is a question. Thanks for the great presentation. You have great data. You're great. There is a question from Alessandro Martiniello from Denmark's National Bank, who's asking which percentage of the Spanish population uses regularly a credit card? First question. And the second question is, and how are BBVA clients with a card representative of the whole population? I guess you got these questions at least 10 times.
Yeah, yeah, that's true. So starting for the representativeness, that is the standard question that we have at every point. In the case of Spain, we have around 16-70%. And this market share is stable over time, but for sure we take into account that we need to correct when we go to the granular data in order to not to be underrepresentative or overrepresentative in any part. So we work with a fixed sample of a fixed number of clients sometimes in order to be sure that we are okay with the market share. And regarding the percentage of the Spanish population using regularly a credit card, it is quite high. The last figure that I have in mind, it is that it was higher than 40%, 50%. So we are happy using this type of data. But for sure, one of the caveats of this analysis is that we are not taking care about the spending with cash. So we only have the traceability of the information with card.
Okay, and let me ask you a question that is more probably philosophical, political, given that among the attendees there are many central bankers. And there is also a question by Christina Wong. I will get back to you, Christina, give me 1 minute. I wonder what kind of deal or agreement you had with your central bank in Spain or other central banks in other countries and with the universities to make them able to work with your data, because this is something that is crucial. Our senior deputy governor talked about that, but it's something that we have to deal about. And if you want to work with this data, I think it's wonderful, and everybody would love to do what you are doing. And I think, sorry guys, but you have to spend 2 minutes on that. Thank you.
Yeah, perfect. Yeah, this is a really important point because this type of granular data that has a huge potential is more useful if we share with the academia or with other public institutions that could do policy making with that. So we have different collaborations and agreements taking into account that the data, the granular data, the raw data is always anonymized and it is on our cloud infrastructure. We sign different type of contracts depending on the project that we are going to develop, but in all of them, we do it with the legal services just to assure that the data has no problem for the clients, and it is possible to use the data between the academia and, for example, the central bank for doing jointly projects. We have more than 5 projects ongoing regarding the use of data with different institutions.
I want to say, Yuri, that actually, when we update this information, we of course share with the central bank or with the ministries, not only in Spain, but in Turkey, in other countries. And we also collaborate not only with central banks, but with ministries and international organizations. Actually, we are working with the CAF, with the BID, with the OECD, we will start to collaborate. So it is, I think, a big project for us. I think it can reach to all of the parts, the private sector and the banking and the official sector too.
Okay, there are 2 more questions, but I will ask them at the end, and if possible, we'll get back to that before the end of this session, because I think it's core, and we have all of us most of the countries have to learn from the Spanish example, because I think it's a great example, and we want to know if it depends on the like on your bosses at BBVA, who are more open-minded, or on the institutions, or both. And having said that, I don't see James. Yes, James is back. So James, if you want to talk, otherwise I will give the floor to Simone. You tell me, James, are you back?
I'm back for a few minutes. Slight housing emergency here.
Okay, so I will give the ball to Simone, and you are in charge again. Go ahead.
Perfect. Okay, Simone. Now we'll have a talk about policy uncertainty and daily consumer card payments. And I'll give you a 15-minute at the 15-minute mark. I'll give you a warning.
Thanks a lot, James. Okay, I'm sharing the slides. Okay, does everybody can see?
Yes.
Yes.
Okay.
Don't press Control L. Good.
Okay, cool. Is it okay? Perfect. Okay. So this is joint work together with colleagues at the Bank of Italy, Guerino Ardizzi and Yuri Marcucci, and a colleague at the Ufficio Parlamentare di Bilancio, Libero Monteforte. Let me jump immediately into the paper with the motivation. Since the Great Moderation period, there was the burst of the global financial crisis and the sovereign debt crisis. Here, this paper is not about COVID, but it's about a pre-COVID period. Our sample end in 2016. But anyway, after the Great Moderation period, these two crises lead to an increase, an immense jump in uncertainty. Uncertainty became key and was considered one of the main forces of the recession, and was slowing down the subsequent recovery. So measuring economic policy uncertainty has become an important subject both in the policy and the academic debate. And this paper asks the following question: does daily payment system data help to investigate the economic policy consequences of burst in uncertainty? And we focus on daily data because in general the literature focused on quarterly and monthly time series, and we want to go a higher frequency, namely daily, in order to investigate if this burst in uncertainty generate what are their effect on payment transaction that are very close, that tracks very well consumption and consumption data in the national account. Let me show you the paper in one chart. This is the road that we will follow. Basically, using text mining technique, we calculate economic policy uncertainty and economic uncertainty indexes using Bloomberg and Twitter. We use the technology put forward by the seminal paper of Bloomberg and Davis 2016. Here in this paper, we basically, I think we were the first one to calculate these indexes on these economic policy uncertainty indexes using Twitter as a data source. Recently, Bloom put forward a nice paper that he presented in Jackson Hole, calculating this indicator for the US economy. Then we use daily debit card payments, namely point of sale transaction, so debit card spending, and ATM withdrawals. They have they are at the daily frequency, so relay frequency, but the series that we deal with in this paper are not granular as the one that Tomasa showed before. This is the aggregate at the national level. It is pretty representative, as I show you in the subsequent slides, but unfortunately we cannot go in depth like Tomasa was doing before. To use this data, we need to clean them because they show strong seasonal patterns. And once we clean them, we use them with local projection and see what are the effect of bursting uncertainty on the flow of debit card payments, and what happens also to consumption. Since this data speaks very well to national aggregates, what happened after a burst in uncertainty. Okay, so in this slide, I resume the main finding of the paper. Basically, payment data, this aggregate series that we use, have interesting seasonal pattern per se. Then we find that strong increase in economic policy uncertainty generate a temporary but significant reduction in debit card transaction that is closely linked to consumer spending. And we cannot tell apart two theoretical mechanisms since we don't have the right granularity of data, but these findings squares well with a precursional saving motive. Like in our sample, we have data from 2007 till 2016. We had the sovereign debt crisis. There was Berlusconi's government resigning. So there were many exogenous political uncertainty shocks that generate variation. And when during the period of the resign of Berlusconi, for example, there was huge uncertainty about the Italian economy, and this could push for increase precautionary saving. Further, we find that bursting uncertainty generate an increase in use of cash. The number of cash withdrawal done at ATM machine after a strong uncertainty episode tend to increase, and people tend to use more cash rather than electronic money. All these results that we find are high frequency, namely daily, we find them also at the monthly frequency, but only if we identify the shock correctly. Namely, we go at the daily level, we identify the shock at the daily level, then we aggregate them and rerun local projection. If we identify the shock correctly at the daily level, following a methodology put forward by a colleague, Andrea Gazzani, together with another colleague, Vigondoa, basically we find the local projection result between the daily and the monthly results are similar. If we identify uncertainty shock directly on monthly or quarterly data, basically we don't get coherence between these results. In the interest of time, let me skip the literature review that is immense. And now, after the COVID burst, many people started to use a lot payment data. Okay. Let me start with the source of the data. Basically, we take data from BICOM, that is the clearing system of the Bank of Italy. It manages a lot of transactions. So just to make an example, the total value of transaction of BICOM in 2018 was comparable to the size of the Italian GDP. There are several instruments that are used, namely debit card. Several instruments are processed in BICOM, like debit card, checks, direct debit, credit transfer. We focus on debit card because they square well with non-durable consumption and services of the national accounts, and because they have strong business cycle pattern. The advantages of getting the data from BICOM is that they are real-time, daily, and there are no revision. Further, we focus on debit card because debit cards are one of the most important payment tool for Italian household, way above the use of credit card or prepaid credit card. And in terms of representativeness, to add on the representativeness, the 66% of debit card transactions are settled through this system of the Bank of Italy. So the system is pretty representative. Here, I just want to show you briefly the fact that, that the dynamic of POS squares well with the one of consumption, where consumption is proxied with the, in this figure you find year-on-year growth rate. Consumption is defined as the sum, the sum of non-durable consumption plus services, nominal, and also POS is nominal. We haven't deflated the time series, and you see that the correlation is pretty high. In terms the average purchase with POS is around 60 euro, while with ATM withdrawal, transactions are on average of 200 euros because of the shoe leather cost. So with this bullet is here to tell you that when we speak about POS, and I will focus mainly on POS, we are really speaking of non-durable plus service consumption of goods that enter these brackets of the national accounts. So the ratio of the values of POS, of point of sale transaction plus ATM withdrawals in BComp over the yearly amount of non-durable consumption services in the national account is approximately 12%. So it's really representative. And also we analyze the relative use of ATM with the relative movements of cash, ATM withdrawals, together with POS, and we see that and this ratio per se is counter-cyclical, namely tends to increase during recession. For the adjustment, let me be really brief. On the left, you see our time series of POS, and on the right, a snapshot. The sample that we cover excludes COVID times. We start from April 2007, and we end in September 2016. The seasonality is super strong. In order to treat it, we use two techniques, and the results in the slides will focus mainly on TBATS, that is this paper put forward by, this methodology put forward by De Oliveira and Van Schneider in a JASA paper 2011. Just briefly, this is the decomposition of the post-time series in its weekly, monthly, and annual seasonality. Basically, we see that people tend to spend more over the weekend in the top right panel. At the monthly level, the post payment tend to be higher at the beginning of the month when pensions are paid, and mainly at the end of the month when wages are paid in the bottom left graph, and the bulk of expenditure is on around Christmas. For what concerns the EPU measure, basically we build them the usual way, Bloomberg and Davis 2016, and the same way we use both Bloomberg and Twitter. The economic policy uncertainty index, we use both Bloomberg and Twitter. Let me show you immediately the graph. These figures are the graph of the indexes. The red line is the 90% band, the 19th percentile, and you see that there are several high uncertainty events, like the sovereign debt crisis in Italy, election, the Brexit, and these episodes focus mainly on the first part of the sample, and there are less episodes in the second part. Here, just briefly, these are our indicator using Twitter. Here is a comparison with Bloom. Basically, the green line is Bloom, and the other three are the three indexes I will show you in a while in the application. basically all of them correlates with the one put forward by Bloom. The econometric framework. Here we use local projection of Jordan. So the specification is really simple. We put in turn point of sale expenditure and ATM withdrawal on the left-hand side, and we regress it on our EPO uncertainty index, a lag of the dependent variable plus some deterministic component. The sample, as I told you before, ran from 2007 till 2016 for a total of 2,400 observation. And let me jump immediately to the result. Here you find the input response estimated by local projection with the tree index on the full sample. Here you find the reaction to a shock, a one standard deviation shock in the economic policy index calculated with Bloomberg. This is the economic uncertainty indicator, and the difference between these two indexes is that the economic policy uncertainty condition on the policy terms. The economic uncertainty do not condition on policy terms like central banks and this kind of things for comparability with Twitter, because to calculate the index on Twitter we cannot add the policy term, otherwise the tweet is too short and we cannot select any tweet.
Is your 5-minute warning before the end of the session?
Sorry, it's finished or?
Yeah, 5 minutes.
Yeah. 5 minutes. Okay, sorry, I was not hearing very well. Sorry for that. So that's perfect. So thanks a lot. You find the input response. The black line are the medians that are collected in the bottom left, bottom right panel, together with 64 and 90% bands. On the x-axis, you find basically days, and these are 60 working days, namely 3 months. And as you can see, after one standard deviation increase in the economic policy uncertainty, you see that payments tend to go down by with a peak response of 0.3 and tend to stay low for a couple of months, and then they go back to baseline. And these results are pretty. The results are plotted for one standard deviation band, but if you think that the sovereign debt crisis was a 10 standard deviation episode, we should multiply this elasticity by 10. So it's a 2% reduction in in the volume of payments of post-transaction. Now, since post-transaction in a month without any crisis is, let's say, a month that is baseline, the total amount of post-transaction in a month is around 20 billions. Basically, if there is a 10 standard deviation shock in a month, we lose around 600 millions. Then if the shock is persistent, as it was the sovereign debt crisis, adding up, you find a sizable increase of this shock. This is analysis by subsample, and basically results are stronger in the first subsample, where there is the Italian government crisis, where there are Italian election, so first subsample from 2007 till 2013. Instead, results tend to be less robust in the second part of the subsample, where there are less significant high uncertainty episode. This is the reaction of the, sorry, there is a mistake here, is the ratio between this is the ATM withdrawals. It's not the ratio, but this is the ATM withdrawals. Basically, after one standard deviation shock of these three EPU economic policy uncertainty indicators, we see that ATM withdrawals tend to increase after 1 month. So people tend to use to go to the ATM, withdraw money, and use less electronic money, probably because they prefer to keep cash for fiscal arbitrage, to make all the kind of payments. Mainly for fiscal arbitrage, things like that. But basically, we find this going away from electronic money and substitute it with cash. We did couple of robustness. Because people were scared that economic policy uncertainty could be confounded with financial uncertainty, but basically controlling, adding to the previous local projection indexes of financial uncertainty, stock market return, 5-year CDS, results go through pretty well. And also, since probably uncertainty could go hand in hand with bad news, we also control for daily surprises on macroeconomic variables such as GDP, private consumption, and surprises are defined like the difference between the value released in the national account on the indicator published by the National Institute and the Bloomberg median forecast. Enriching the previous local projection with these surprises, we don't find any significant modification of the impulse response, meaning that uncertainty is a driver per se. Finally,
this is your
over.
1 minute or less warning.
Okay, thanks a lot. Just to conclude, we identify the shock at the daily level using all the control that I showed you before. We aggregate them and rerun a local projection at the monthly level. And here are the results. And we get similar magnitudes. We get similar results for the elasticity we found previously. And I leave the conclusion on the slide. Thanks a lot for listening.
Okay, excellent. Thanks for that talk. I guess we may as well go to the discussion that I gave, and then we'll turn it over to the floor for any questions. So let me just share my slide.
You should be able to.
Yep.
Share. Don't press Control L.
Don't worry. Okay. Can you see my slides?
Yes, perfect.
Perfect. Oops. Okay. So so these are just some thoughts I had on this literature of the several interesting papers we saw today. This area I think is very useful for nowcasting as well as other issues. I'll go over that in a second. Before I do, though, the usual disclaimer applies that these are my views and not necessarily the views of the Bank of Canada. So with that, I'll maybe give a high-level view of where I see this sort of the literature these papers are contributing to. So I think so they're all asking interesting questions using payment system data, which is incredibly useful for a wild variety of questions in the literature, and that's mainly because it's very granular, it's very timely, so it's available on a daily basis, sometimes higher if you have access to the clearing and settlement system, and you have the right data, so you can answer a lot of different questions in a lot of different areas. So they're not all covered in the papers today, but you can sort of see. You can ask questions about banks' profits and losses because they're in various finance questions, because payments data is ultimately, they're either assets or liabilities about banks' balance sheet. And then a lot of papers today showed you can think about household balance sheets, because these are instruments that households use to make payments for goods and services, so that various macroeconomic questions, especially nowcasting type questions, can be answered. And another area, because payments is basically the interface of monetary economics and international industrial organization, you can think about the sort of the payments as the observed outcome of a competition and activity between different platforms or on different platforms. So you can ask various I/O questions about competition and market power and things like that. And also, they're not surveys; they're basically data coming from different systems. So there's typically no sampling survey issues. So there's we don't have to worry about sample selection in that case. But that being said, there's still a lot of sample selection issues, mainly coming from the fact that these are outcomes of market interactions. And a lot of my discussion questions will probably touch on some of these where I see there's a potential sample selection issues. So I'll go over all the different papers, and then maybe after that I'll give the authors time to respond. So going in order of what we saw, the geography of consumption and local shocks, and this is a very interesting paper because the authors did a good job presenting the paper, and basically shows that space is important. So space is the final frontier in a lot of economic questions, and the authors show this by doing a nice exercise by leveraging geographic characteristics of card purchases, because they have a payment processor that has the geographic location essentially of the payer and payee, and they can link these geographical issues to sort of macro quantities and show that inter county spillovers in the U.S. are really important. So a couple things I'd probably want to think about for the authors is, first, they're using all the counties in the U.S. So there's drastic, like many orders of magnitude difference in population density from these counties. So I wonder how the authors would control for this, because the density of a county is probably related to its size. So you have big counties out in the prairies that are virtually uninhabited, and this probably is related to being a high exporter or not. Especially since when they got the data from their payment processor, there's a category suppression in that if you could potentially, I'm assuming the reasoning is, if you can potentially back out the identity of a firm or an individual, the payment processor will suppress that data. So with big sparsely populated counties, it might be that there's a lot of category suppression. Then that leads to sort of what my third point is that are there sample selection issues in the payment processor? It's a large payment processor, but they might have different geographic concentrations. So for example, in Canada, we had one big payment processor that was run by a credit union in Quebec that had a very large market share there, but very little in the rest of the country. And so that, thinking about that, where's the payment processor, where are they geographically strongest, and how would that affect your results? But another kind of cool thing to think about is sales taxes, right? Sales taxes in the US are typically county or even in city level, and this data set might let you think about how sales tax affects intercounty imports and exports, basically. So turning to the next paper, liquidity in Canada during the coronavirus pandemic. So this is a sort of a nice example of using a slightly different data set of credit bureau data to estimate this Markov model. It gives us a great, interesting tool about could be very, very high frequency changes of basically debt balances, because the credit bureau sort of samples the people's balances through time. So it's probably a great tool. I'm sure it'll be used a lot by policymakers. Now, the two questions I have here is, first is sort of this model specification question. I sort of hinted at it with Leland's presentation, in that he looked at presented the credit card balances, but they use a HELOCs as well. And so the credit lines, when they estimate the excess debt levels or negative debt levels, the HELOCs actually have an increase in mass at the highest level as well, which I think is kind of interesting. And that's why I'm wondering if it might be useful to estimate a joint distribution of credit lines and credit cards, since you have so much data, because then you can tease out if people are sweeping their credit card balances onto their lines of credit. What is their aggregate level of liquidity, right? And also another thing to think about, and I was thinking about this during the presentation, is if you look at the line about the credit card balances, it's increasing over time. And this is a policy, a problem that's been explicitly stated in our FSR at the bank, is that personal indebtedness has been increasing over the long run in Canada. So thinking about how to take into account that non-stationarity and the fact that balances are increasing overall. Maybe instead of doing this in levels, doing this in growth rates, and taking out the trend would give you maybe I think it'll just take care of that stationarity question. So coming to the paper on tracking the COVID crisis with transaction data, this is kind of an interesting data set coming from BBVA about their cards and payment terminals, right? And this is a nice exercise of what you can do in terms of nowcasting with these different sort of payments data, right? And so they show that there's how there's a strong reaction to lockdown with a strong recovery, how it changes between different postal codes in Madrid, so that you can sort of see that the higher income deciles at the postal code level have changed their consumption more, and how this also changes mobility patterns, because like the first paper in the session, you can use that geographic location. A couple things that to think about here is that the authors are very clear that they talk about non-durable consumption data, and there were some questions in the chat about this. But my question here is, they make a point saying like cars and houses are not bought by credit cards, but I'd say other lower dollar consumer durables are bought by credit cards. So electronics, home appliances are, I would argue, probably exclusively, at least in North America, bought by credit cards. So that would contaminate the data. Another thing to think about is DIY supplies. I'm assuming that means, as a North American, I'm assuming that means home improvement. When we look at the credit card data at the bank, you can see there's this huge increase in DIY spending or home improvement spending over the last couple of months from the lockdown. So that would be a consumer durable, I would think. So thinking about that shift in consumption and how to clear it, from the data so you get non-durable consumption. One comment I'd say, maybe the authors should think about how many active BBVA payment terminals there are at any point in time, and how does it change? Because people are presumably moving to digital commerce more over the lockdown, and that means there'll be a shift from non-observable to observable payment types, i.e. cash. So there was a question about this in the discussion about controlling using ATM withdrawals, but I'd say those could be imperfect because there's a precautionary motive for cash withdrawals. So my colleague Kim Hyun, whose paper is on the presentation, him and his survey team have shown using during the COVID some surveys that people increased their cash withdrawals, right, and took some more cash. So looking at payment terminals as well, like that extensive margin of the ability to make a card payment, might be a useful way to control variation. And on the last paper, the policy uncertainty in daily consumer card payments, this shows you sort of how you can use these payment data because they're very flexible, and cross them with other non-traditional data like text analysis, these uncertainty measures, to sort of get a clear measure of things that we could never even have done before. So like high frequency consumer behavior relative to uncertainty. And before I go on to the measurement questions I have here, I'd sort of say another point that I don't have in the slides, but I wrote down, is payments data is interesting because there's various areas in the chain that you can measure it at. So BBVA was measuring it essentially at the bank level. The first paper in the presentation was measuring it at the payment processor level. Right now they're measuring at this current paper, they're measuring it at the settlement level, settlement of the balances between banks. And then in addition, you can also, if you talk to the card networks, there's a possibility of getting that from the card networks itself. So they see it. And then each one has a different sampling question. So for example, in this paper here, it doesn't seem like credit cards are in your sample specifically, but I'm assuming, since you probably have access to the different payment settlement systems at the Bank of Italy, you probably can maybe get some measure of it, because ultimately credit card balances will be settled between banks via probably some central bank funds. So that they might come in net or gross, I don't know, but there's a possibility there. So I know, like in the Canadian case, I think they're settled through our wholesale system, but they're not in our retail system. And maybe another question I have is about this payment behavior relative to the uncertainty, right? So and this goes back to this durable, non-durable question I had in the previous paper. There's changes in potentially durable and non-durable consumption, because these authors are looking at debit cards. It's probably more likely that's purely non-durable consumption. But there could be a question of switching my payments. Instead of buying a meal, I feel more less uncertain about life, so I'll go buy a stove or get my kitchen redone, right? So there'll be some changes in behavior through time that you need to think about that. And one of the reasons I brought up the different payment process, different legs in the payment chain, is the question here is, what about on-us charges, right? So on-us changes. So payments, they're in the settlement system, we're only seeing the net, or the amounts that go between banks. So if the payer and P are at the same bank, you're not going to see it in a payment system data. Now, depending on the structure of the banking system in the country, that may or may not matter. Like Canada has essentially sort of 5 big national banks that are relatively spread across the country, so you don't have to worry about that. I'm not sure about Italy, if there's sort of more regional banks. So if there could be systemic changes through time. So calling back to the first paper about accommodations and sort of meal charges and spectator sports are more likely to be cross-region rather than within region. So thinking about how that on-us changes over time might be a thing to think about, that paper. So with that, I'll conclude. Overall, I say all the papers are great. We need more of this work, and I think they're all great papers that need to be read by everyone in the audience. With that, I'll maybe turn it to the authors to maybe respond to my comments. And we can start in the same order that we did before, and maybe Abe, if you want to start off the responses.
Sure. Thanks, James. Those are really excellent comments. I think you can focus in your comments in terms of just the thinking about the data quality and issues of selection and is on my mind. And I think in our work we've spent a lot of time trying to improve that. Trying to do the imputations, cross validation, and checking the data. But I think you're right to focus on that and to think if there's additional ways to think about improving and accounting for selection issues and things like that. Again, I think we have pretty good coverage in the data, but the more we can improve the quality of it, the more questions we can answer accurately. I also really like the idea of focusing on local sales tax. After you made that comment, I started looking for data sets and where can I find local data on sales taxes. And so I really do appreciate your comments. Thank you.
Thanks. So hopefully you can find that sales tax data, because that'd be kind of a cool second paper extension. So I'll maybe turn it over now to Leland or Kim, I think, if he's online.
Yes, thanks. Yeah, I enjoyed the comments. I thought they were very insightful, and they reflect some of the issues we've been studying in our longer research program. We've considered a portfolio approach. I focused on credit cards in the presentation, but we also look at home equity lines of credit. And I do think it's interesting that there's that jump in the high balance home equity lines of credit. And one thing we could look at there is to test of a hypothesis whether or not it's related to pent-up demand for homes, where people postponed purchases until some of the economy opened up, or if they're actually new loans from people in financial distress. And it is something that we could check, cross-reference with their other accounts. And with respect to the conditional stationary distribution, it could be the case that the distribution changes, and not just, or the nature of the transitions between the distribution changes. And my hypothesis there is that it seems that after March and April, June, July seems to be very close to the kind of transitions we're seeing. But that is something we could test with the framework and actually compare the distributions in the columns of the transition matrix to be able to identify statistically whether that's the case. So that would be worth exploring to characterize this better. And the big point I like was the notion of a joint distribution between these two assets. And I have to say, this is something we considered earlier, and we ended up writing about it in my diary rather than the paper because of the nature of the shift in the distributions. It moved left instead of right. But the really interesting part about this is for the consumers, if any, that are facing a constraint, they might borrow from their HELOC loan first, and then once they reach the constraint, they can then move to the high interest credit card loans. And so that would be very interesting to explore that. Two approaches we considered. The easy way conceptually is model a joint location in the two distributions at the same time, but it increases computationally. We were also exploring a copular approach to measuring the joint evolution of the two distributions at the same time, and that is something that would account for the dependence and the nonlinearity of the relationship. It ended up on the cutting room floor for this paper in particular, but I think it's worth investigating in case there's a subset of consumers in that corner that are facing that constraint. That would be interesting to expose them here. One last point about the growth. Yes, we were concerned about that. We stuck to a sample 3 years back, but you can see this trend over time. And if we take that into account, I think it would be very simple to put that into the process we're using. But when we see the growth over time, it might even have a bigger difference in the shift of the distribution to the left, but it would get a more accurate characterization of what's going on. So I think that's something we can implement and give us a better picture. So thanks very much for all the comments.
Well, happy to provide them. Hope to see the next version of the paper. And maybe now we'll turn to the BBVA folks and Tomasa.
Okay, thank you so much for the comments. We really appreciate them. Let me go through them. Regarding the first comment for the measure of consumer durables goods, here this is a really important issue, and actually we are trying to incorporate all the information regarding bank accounts and also purchases that are done with credit during our system in order to complement this information. But an important point just to say is that comparing with the retail sales indicator or with all the consumption proxies and indicators that are published in the official figures, that's true that the data from credit and debit cards replicates quite well the evolution. So we think that we are not losing information for the nowcasting of the consumption activity, but that's true that for knowing with and working with more granular information and knowing how these expenditure patterns change for durable goods, we need to incorporate that issue. We are working on that. So thank you. So for the rest of question regarding the number of active BBVA point of sales, that's true that we studied for cardholders and point of sales, and the market share is quite stable over time, but we were more worried about the cardholders, because if I I cannot show my screen, but don't worry. In the presentation, what we see is that more than 2/3 of the information comes from payments done from credit and debit cards, where we have the information that goes to our point of sales or to other point of sales. Then, regarding our point of sales, we also have all the data, but they were minor. So we were more worried to control for the market share of cardholders in different countries than the point of sales. But this is also a good point to take into account. And finally, regarding the 18 withdrawals, that's true that also people could use this money for saving purchases. Moreover, right now with the uncertainty and the COVID crisis, this could increase. But the empirical work that we did for all the countries that we study showed that there were no changes in patterns, apart from in Peru, where we observed that they increased the use of credit card, but we don't observe an increase in ATM withdrawals that we could see. We could think that it is for saving purposes. So I can share in the chat a link to a presentation that we have for all these countries, where you can see this data in detail, and it is also interactive for getting the data from our website and working with it. So this will also be useful for this question. And no more from my side. Thank you so much, and we will really appreciate your comments and interest. Thank you.
Thank you. Thank you. Thank you for that great presentation. So, and then maybe the last one we'll turn over to Simone about the uncertainty.
Hi, James. Hi, all. Thanks a lot for your great comments. I would like to reply to the first. Okay, are credit cards in your sample? Actually, no, we didn't use credit card in the sample because since you cannot separate well if credit cards belong to households or firms, actually we took the choice of just looking more at point of sale transaction that it's really more on the household, so at the household level, and that's why we map it more on non-durable and services, because like credit cards, generally you buy furniture, you buy durable and semi-durable goods, so like we want to have more a cleaner effect on non-durable implication for non-durable and services that tend to move less with the cycle. Like for sure, durable move more with uncertainty, but it's sort of preliminary evidence that also non-durable consumption and services move if uncertainty spikes really high. And then BComp is net or gross payments. BComp compensate the settlement. The data in BComp are gross. So we have gross payment, and for the payment behavior related to uncertainty, you are totally right, because like people could change the payment choice according to its leverage, or but like since we really want to focus on non-durable and services, like like leverage is important, clearly, but for financing non-durable consumption is less of a problem. If durables are put into picture, then the problem increase, and for sure leverage the net financial position of the individual becomes crucial, but we don't have it in this aggregate data. But that's clearly a great great comment. What about on us changes? Okay, yeah, you are totally right. We can see the total of on us changes we don't observe because they are transactions that are compensated. Actually, we don't observe at the daily frequency because like the data, I mean, if I use a card of Bank A for a transaction with a point of sale that is issued by the same bank, like the transaction that remain internal to a bank, we don't observe them at the daily level, but we observe them in the so-called matrice in the financial accounts that are I think monthly or quarterly. So yes, you're totally right, but like we don't see a huge difference when we take these not on us transaction that are compensated by the system that we use. We aggregate at the quarterly level. We don't see tremendous differences in the pattern of the time series with the on us and without the on us. But anyway, like all your point, they are all very important, and we will take care of all of them. And really, thanks for reading the paper and all the rest. Happy
Thank you, and thanks for that presentation. Now, I think we're 5 minutes into the coffee break, so I'll turn it over to Jury if we want to.
Well, for me, it's fine. You know, even yesterday in the other virtual room, I took the coffee break as an opportunity especially for the attendees who cannot unmute themselves. If they have questions and they want to speak up to the panelists, just raise your hand or write in the chat and I will unmute you so you can ask questions, to make it more lively. Unfortunately, we cannot have an Italian coffee or we cannot share pastries, so, but it's okay. It's fine. I think, we gathered more or less 700 people for this conference, so it would be probably impossible to have an event in person with those numbers. So let's see if there is anybody who raised questions. Otherwise, I'm going to ask questions to Tommaso and Alvaro, of course.
Yes.
But you can do too, right? Abe, James, or the other Deepa, of course. We have also the panelists from the next session. So
Maybe one question I can have to take to Tomasa is about the ATM withdrawals. So I think another thing to think about, and I've been thinking about this recently, is you see the withdrawals, but since you presumably have access to sort of the bank level information about cash deposits from the sort of the bank accounts for merchants. So this might give you an idea of how much cash is being used for payments as well, right? So you can sort of see, because that'll help you disentangle if there is a precautionary effect, for example.
So this is a really interesting point. We haven't investigated on that, but this is a good point to see the data. One of the most interesting part of this type of data that we are analyzing is that actually you have a comprehensive view of the individual, of the client. So you can see their savings in the bank accounts, their transfer, consumption with credit card. So this is a good point. Thank you. We will look at it.
This is James. One interesting thing about the ATM and the credit card performance is normally in the crisis, and I'm talking about in the case of Turkey, the financial crisis and the COVID crisis in Spain. What we show is that the cash withdrawals decrease much more than the credit cards. So this is an effect. So normally we have to correct a little bit. It will be normally more deeper than the credit and debit cards, because normally the people of this segment would normally use the cash. It is more adjust much more rapidly than the credit card holders.
Okay, cool.
that is great, I think. So, oops, yes, that's the the end of the session, right? So let me thank you, all the panelists. Thanks, Tomasa, Leland, Abe, James, and Simone. Well, that's it's not the same, but thanks so much. Let me stop then the recording for this session, and I will move to the next session. Thanks very much, guys. I think it's very interesting, and it's the way to go, probably. Tomorrow, we are going to have a closed session with some colleagues of other central banks talking about these issues. And I ask you those questions, Tomasa, because I think really you are a good example. But we have to understand if this good example is because you have a management that is very open-minded, or we would like really to imitate what you're doing in Italy, in Sweden, I'm naming some of the countries, probably in almost all the countries that are here in this conference, for sure. So let me, I will start the new session. The new session, the chair is going to be Ines. I think she's here.
Yes. Hi.
Everybody's here. Yeah, you can talk. I will give the ball directly to Deepa, so she can present. And again, Deepa, as you know, don't press Control L or Command L, right? Because otherwise you're going to kill your WebEx session. Thanks again. Ines, you are the leader.
Okay, so good afternoon, everybody, and we start this very interesting session on natural language processing and macroeconomic applications. And we will have 3 short presentations of 15 minutes. And the first is on oil shocks and textual analysis approach. So please, Deep, I leave the floor to you because we are already late. Please, Deepa.
Great, thank you. I was just working on unmuting myself. So can you all see my slides?
Yes, everything is fine, Deepa, go ahead.
Great. So thanks for including our material in the program today. I'm not watching the chat, but my co-author Daniel Diaz has joined us today. He should be watching the chat. We welcome questions then or afterwards. Our paper is on looking at oil shocks using a textual analysis approach. So we're going to use textual analysis of a key oil industry news source to measure global supply and demand developments. Our work is going to develop a systematic and automated process to read the news, analogous to the informal approach that we were employing as Federal Reserve Board oil analysts. The publication itself is called the Oil Daily and the International Oil Daily. They're the flagship publications of the Energy Intelligence Group, which is a well-respected publisher. The data from the Energy Intelligence Group, for example, is used by OPEC in their own internal deliberations. Our work is going to provide a quantitative narrative of market conditions in real time as the news develops, because we're developing that quantitative narrative from these daily articles. As a result of this daily textual analysis, we can develop earlier data availability than, for example, with official statistics on oil production or industrial production or global aggregate demand. In addition, oftentimes in the oil market, when we're looking for daily available data, we look, instead of from the oil market, we look at metals or equities to give us a sense of demand. And our work is going to allow us to get that daily sense of aggregate demand, but from an oil-specific source, which is these articles. In addition to being able to apply our methods to these daily articles, we of course also use the publication archive to relate text-based indexes to supply, demand, and prices over history. Using that publication archive and the history of these data back to 1992, we can identify supply and demand-driven oil price dynamics using a structural VAR. In terms of our contributions, textual analysis is obviously very widespread at this time. One of our contributions is to go beyond sort of counting the number of articles that think about these particular issues. And instead of counting just the number of articles within general publications, rather we're going to be counting phrases within those articles. So our set of articles are all oil related, and we're going to be looking at the phrase counts within the articles to get a sense of the relative importance of supply and demand. Additionally, we're going to drill down even deeper than just supply and demand and think about the direction of supply and demand. So we developed some dictionaries of increase and decrease words and think about supply increases, supply decreases, demand increases, and demand decreases. You can sort of think about this as sentiment analysis for oil markets. But in sentiment analysis, thinking about a positive or negative sentiment for oil more generally doesn't really get at the meat of the problem in oil markets, because positive or negative oil prices may be positive or negative, or vice versa, for particular countries, for consumers or producers, whether they're driven by supply or demand. So by really going after the direction of supply movements and direction of demand movements, we can get a deeper understanding of market conditions. Lastly, by using our textual analysis in a scripted way, we're preserving replicability and straightforward updating. So there was work in the past by Wu and Cavallo that is closest to our own work that similarly combines a narrative and quantitative approach and looks even at some of the same publications from the Energy Intelligence Group in order to categorize events that occurred as being supply or demand related. That work, while being very interesting and very important, is very difficult to replicate and to update because it involves human auditing of all of those articles. So one of our main contributions is to extend that type of quantitative and narrative approach by using information from the news articles, but by using natural language processing to make it very easily replicable and easily updatable. In terms of what we actually do, we develop 4 directional phrase count indexes. So we're going to, as I said, construct vocabulary lists for supply, demand, increase, and decrease. And we're going to count the number of times a supply word is found in proximity to an increase word. The number of times that we see supply in proximity to an increase word is going to be a determinant of our supply increase index. And then we're going to repeat that method to get an index for supply decrease, demand increase, or demand decrease. once we have those phrase counts, we construct the index as shown at the top of the slide. So we're going to take the number of phrases, for example, supply increase phrases, and then we're going to do some normalization, where the normalization is simply about the number of words in a particular article or the number of words on that particular day. And then once we have those sort of daily measures, we also want to normalize by some reference period. So we have 1995 to 2004 as our benchmark reference period, and we think about particularly high supply increase or supply decrease measures, or high and low demand increase or demand decrease measures as relative to that reference period of 1995 to 2004. So doing our textual analysis, we're going to get these 4 directional indexes: supply increase, supply decrease, demand increase, demand decrease. And of course, we can subtract those indexes as well and get our 2 net indexes. So a net supply measure and a net demand measure. In the slides that follow, we have some work that uses those net measures, but I'll mostly talk about the separate measures. We think that, so a supply increase story might be one where there's an oil discovery or an increase in output by a particular country. A supply decrease measure might be one where there's sort of a pipeline outage or an oil field that needs to stop producing for some reason. And we think that there are separate shocks between increase and decrease, things that are happening in the market all the time. And so we're going to allow those 2 directions to affect the measurements separately. In the interest of time, let me skip over a couple of these exhibits, but go actually straight to the net supply index. Here what you can see is that the blue net supply index actually decreases quite a bit in 3 distinct episodes. One of them is in 1997, another is in 2001, and then in 2007, 2008. So in 2001 and 2007, the reduction in supply makes sense. It's right around the time of these gray bars, which are, of course, U.S. recessions. In 1997, 1998, there isn't a U.S. recession, but of course, there was the Russian financial crisis as well as the Asian financial crisis around this time, when there was a decrease in global demand and then a responsive decrease in global supply as well. So our index does seem to track global developments. In order to validate these measures, we're going to look at contemporaneous regressions. So we're going to regress other statistical measures of supply, demand, and prices on our indexes. So we do both a contemporaneous regression and a 12-month ahead regression. In the contemporaneous regression, we're looking at the change in oil supply, demand, or prices in the same month as our indexes of supply increase, supply decrease, demand increase, demand decrease, with a number of controls for previous measures of supply, demand, and prices. In our 12 months ahead regressions, we're going to look at how indexes this month are going to affect supply, demand, and oil prices over the next 12 months. So here's the table of the results. Obviously, in this presentation, I don't have time to go through all the details, but the key thing to look at here is the first 2 numbers in the first column. So here you can see that when we regress oil production on our 4 directional text indexes, production rises in months with higher supply increase measures and falls in months with higher supply decrease measures. If we look at real economic analysis or industrial production, we can see that industrial or world IP measures increasing with demand increase measures and decreasing with demand decrease measures. We also have magnitudes that might, directions and magnitudes that might be expected when we think about the relationship between our indexes and WTI spot as well as WTI futures prices. We can also look at the 12 months ahead results. So again, when we have, for example, the supply increase measure is increasing, we see that's associated with an increase in oil production over the next 12 months. Similarly, when we have a higher demand increase measure in the 3rd row, we see that real economic activity is higher over the next 12 months. So we think that these textual analysis measures are having not just reflecting not just the current news, but also contain prospective information about what might happen in the oil market over the next 12 months. So in addition to doing these validation measures, one of the key advantages is that we can use this information as well to estimate a structural VAR of the oil market. In order to do that VAR, of course, we need to apply some assumptions. What we're going to do is assume that in the short run, the supply and the demand sides of the oil market only interact with each other via prices. So we have that our 4 directional indexes are all affected by the price in that particular month. We also have that prices are reacting to all 4 of our directional indexes in that month. One of the benefits of moving from using statistical measures of oil production and IP to using just our text indexes and prices is that our text indexes are available on a daily basis. Instead of using a VAR on a daily basis, we're actually going to aggregate it to weekly. But so the next results I'm going to show you are using weekly aggregation of our news signals instead of monthly. First, we have our short-run dynamics, where you can see in general that the supply, the prices that are 4 directional indexes react as you might expect with respect to prices. We also have that prices react in the expected direction with respect to how our news indexes are moving. So that is to say, prices are falling when the supply increase measure increases, prices rise when the supply decrease measure increases, and so forth. I'll skip over the error variance decomposition for now. I'll just say that in the paper, and of course these slides will be posted for your perusal later, we also have impulse responses, which do seem sort of show in the expected directions of how the structural shocks are affecting oil prices. And then the last thing I'll show you is a decomposition. So using that structural VAR, we can sort of back out or estimate the shocks that occurred over any given period and use the estimated coefficients to think about when we saw oil prices move, how can we decompose that movement into supply and demand developments? In addition, when we think about a particular period, here May 2014 to February 2016, we can think about how much does this do these shocks, we have expected shocks that took place before May 2014 that still affect the price movements between May 2014 and February 2016. So this expected column is thinking about the price movements that occurred after May 2014 based on the shocks that occurred before May 2014. And we can see that, in fact, in May 2014, we perhaps should have expected a great decline in oil prices, largely coming from the supply increases that had occurred even before May 2014. In addition, we have unexpected shocks. So during the May 2014 to February 2016 period, we had additional positive supply increase shocks, which of course brought prices down. We also had demand decrease shocks that brought prices down. We had a negative effect coming from demand increase shocks. So that is to say we had fewer demand increase shocks than usual. And so demand increase also exerted a negative pressure on prices. Putting all that together, we of course are able to explain quite a bit of the decline in prices that we saw. And then these gray bars are what we call non-fundamental price shocks, or in other words, the residual from our VAR. So let me conclude. Using textual analysis, we're able to construct indexes that contain information about supply and demand developments in the market. These indexes correlate well with existing measures of oil supply, demand, and prices. They contain substantial information about current and future oil price movements. We can use those indexes to estimate a structural VAR model of the oil market, and those results are in line with economic theory and are of plausible magnitudes. They're also in line with existing literature explaining, for example, the oil price crash from 2014 to 2016. I'll conclude there, and I look forward to your questions.
Thank you very much, Deepa. It was a very interesting presentation. I think we can collect questions at the end of the session. And so I will give the floor to Eugenia Passari for the presentation of reading the news, selling supply from demand in commodity markets. So a second.
I pass the ball to Eugenia.
Yes, okay, thank you. So please, Eugenia, the floor is yours.
Thank you, Ines, and thank you, Deepa, for the very interesting paper and presentation. So this is joint work with Sarah Mouabi and Adrien Rousset-Plana, and it's pretty much a very preliminary stage work, and as usual, many questions from you will be beneficial. It's just to give you a flavor of what is to come in the following weeks and months. So the views are our views. They do not necessarily reflect the views of the Banque de France. So with this paper, we construct indexes of commodity supply and demand using, as discussed before, computer-based narrative approach. Essentially, our aim is to start from a very general framework and to catch a market-wide commodity sentiment instead of focusing on a particular market. And then we tailor our approach to cover other commodity categories, right? So we want to span the whole market. So we're aiming at providing a flexible and unified approach. And essentially, those indices can be used independently on their own or improve structural model-based predictions. We are able to provide higher frequencies, especially when we focus on our main composite index, so we can work with daily data and mitigate the temporal aggregation bias in prediction by doing so. And essentially relying on narrative measures, as the previous paper, one of the good things that it does, it helps relax the orthogonality assumption between supply and demand shocks. That essentially is a assumption in structural approaches. So I don't want to spend a lot of time motivating this work. Deepa has already given a lot of motivation on the economic front about the oil market in particular. I would like to emphasize, and the angle we're taking mostly in this paper and in follow-up work that I have in commodities, is more of a finance angle. So essentially, given the recent increased flow of institutional funds into the futures market of commodities, a process that was termed as financialization, we do have also important implications for portfolio allocation and market segmentation. So although this is a very important endeavor, essentially putting these supply and demand components into different buckets is a non-trivial endeavor. And a lot of model-based methods are often subject to the endogeneity critique. So given the time, I won't go in detail through the literature. The way we see this paper is mostly in the recent strand of papers that use textual analysis for the measurement of various economic outcomes. Main inspiration for us is Baker, Bloom, and Davis, but we also talk to the literature that tries to identify supply and demand shocks mainly in the oil market. And we have many contributions by Lutz Kilian and co-authors, and also by the previous presenter herself. When it comes to methodology, we use a 4-layer approach. So we try to achieve this new simulation in 4 steps. So number 1, following Baker, Bloom, and Davis, we focus on news intensity or news coverage. So we employ the number of commodity-specific articles that are published in various outlets at a daily frequency. And we complement that with a content analysis that pins down words and word combinations that essentially gives direction to supply and demand factors, pretty much in the line of Deepa and her co-author. So essentially, this part is largely inspired by their work. For us, there is a difference there because our starting point is the composite index. So we start, and the beauty, I think, of this work and what takes us to a more general approach is that starting from the composite, we only need to apply 4 lemmas for supply and 4 lemmas for demand, and you will be surprised how rich this is already across commodity markets. And for individual commodities, we enrich those dictionaries and then provide them with standard directional dictionaries that are used in textual analysis. We have a next step that is a refinement step. So we overlay this process with additional algorithms that essentially take care of a big number of exceptions. Those exceptions are different per commodity category. And also we take care of negations, which is a common issue in this literature. And last but not least, and what is now work in progress, is the creation of thematic sub-indices that capture particular weather developments, financial developments that are important for commodities such as gold, trade wars, or the COVID-19